It is my pleasure to welcome Barbara Hughes from Nano, Aditya Subramanian and from Milwaukee Tool, and Susheel Gogineni from the Volta Foundation, who will be sharing perspectives on uncovering obstacles in materials qualification. All right, so let's get started. Before we get into the questions, I just want to give a quick primer on why this is important. We have quite a lot of people here today, and so it is of interest for a lot of folks in our industry. This is important because this process is probably the one that has the most friction in all of the battery industry. There's a lot of really, really promising technologies out in the field. However, the valley of death is very wide and is very deep. And so today we'll be discussing some of those obstacles that we see from the customer, OEM, and also the material supplier side. For those who are new to the field, take this as your primer about what to watch out for if you're in a technology company or if you're working at an OEM or a cell maker. And for those who have been in the field for a while, this is valuable because we're trying to introduce a new framework for folks to think about this process so that we can hopefully reduce that friction that we have in materials qualification. All right, so with that being said, we have Barbara, who's the VP of Energy Storage at Nano, Aditya, who's the Vice President of Cell Engineering at Milwaukee Tool, and also Susheel Gogineni, who was previously a manager of battery manufacturing design at Apple, and also senior manager of battery cell design and manufacturing at Rivian. He's currently a research fellow and a volunteer at the Volta Foundation. So welcome to all of our panelists. I want to ask an introductory question that will kick off a conversation for our panel, and this will go to Susheel. From a very high-level perspective, why is materials qualification so hard to get right from the customer side?
No, thank you, Michael, for having us. I think this has been a wonderful session so far, and I'm excited for this next 30 minutes. And so battery materials qualification is always something that feels like something that's just out of reach for OEMs, because you kind of look at a new technology or hear about a new chemistry that's going to be having huge improvements for the product level. But the couple of clear mismatches that come back is the evidence that's actually available at the time when we need to make those key decisions on a product level end up not being there. And that means we either are working with insufficient data or data that may not be exactly applicable to our particular product. So the benefits are some things which are not super clear for us. And that becomes the first hurdle. And second is we always have to understand what are the trade-offs and what does that, what are the impacting scenarios that will end up potentially causing a manufacturing challenge or a worst case recall issues as well. And when you consider all those variables, the sheer risk levels sometimes just outweigh the benefits, or at least the perceivable benefits. I think that becomes the biggest issue there.
Yes, I absolutely agree. And you're effectively being the gatekeeper for this new chemistry or risk. If something goes wrong, then it's on your responsibility to take care of it.
Right.
Perfect. I have a question for all the panelists to then broaden the perspective a little bit. So Aditya is on the customer side, working with cell makers and material suppliers for new innovative technologies. Barbara is on the material side with their ALD technology and also their battery manufacturing efforts for forged battery. And Susheel has been on the OEM side. And I've also had some experience on both the materials and also OEM side. And we've all likely experienced technical, commercial, or even organizational hurdles in materials adoption for next-gen chemistries and technologies. And I want to ask each of the panelists which hurdle, so technical, commercial, or organizational, so meaning that like you're not able to convince your higher ups or VPs or such to take this risk, poses the largest risk of killing a program and why. I'll start with Aditya and then we'll move on to Barbara.
Yeah, that's an interesting question. As I was thinking about it, I was thinking about what each of those things mean in our world, and then what the technical risks are or where it falls, typically on the promise of what it can deliver. I feel like the promise always remains. that'll always be intriguing. The prize is always out there for us if you put the right effort. So the technical piece is not necessarily where things falter. It's the promise on which the project actually survives. Then the next piece I was thinking through was the organizational piece, which is very interesting because typically, if the promise is worthwhile, the organization will typically align behind it, especially depending on who the executive champion is for that particular project. So typically solvable, certainly some challenges, but overall very solvable. So for me, the answer is very easily commercial. That's where the rubber meets the road. And that's where the different business models also come to an head. OEMs have their own ways of what they're trying to optimize for when they're running a business. Suppliers, partners, other sub-suppliers have their own business model and way to commercialize the technology and bring it to market and make money. Terms as well as pricing, along with the promise of the length of the relationship, all of these are very difficult to nail down when you're trying to put it into words that are legally enforceable. And typically the place where things falter, based on my experience, and also the biggest hurdle, I guess, to answer your question very specifically, the biggest hurdle to climb is that it takes more organizational momentum and effort to get over that hurdle.
Yeah, I can definitely see that. Barbara, from Michelle's perspective, what would you say is the most difficult?
So I agree with Addy that often the technical challenges are the easiest to identify and troubleshoot. So that's usually something that's addressed pretty early on before you're even moving on to the next phase. And so that's not usually the hurdle. I'm kind of as someone on the materials side as well as on the cell supplier side. I've found that, of course, commercial hurdles can be the most dangerous because, whatever new material you are bringing to the table has to have benefits that are going to outweigh the cost of adoption for your customer. But I've also found that, especially when working with large organizations, and this is not a knock to large organizations, there's always a risk of restructuring happening in the middle of a project. Okay? And that means that you run a risk of losing, priorities can shift with teams, and you can lose your material champion within the organization. So I think it really depends on whether you're looking at it from the OEM or the cell supplier or the material supplier. But sometimes, often for us, the biggest risk is that qualification takes so long that you can actually, mid-project, have everything really shaken up.
Really? And Susheel?
So I think, I kind of have a slightly, uh, other approach there because I do agree that I think commercial and fundamental business viability itself is something that needs to be evaluated very early on and making sure the company that you're trying to source new material from is stable and can actually scale this product. But from an OEM perspective, one thing that I've kind of seen it happen multiple times is if the some of the risks can only be identified at the final product stage. Like you need to kind of change a material, but you got to go and redo all of your crash testing at the vehicle level. I think that is going to be a very tall mountain to climb for OEMs to be able to take on the challenge. And because if you find out that late in the program that something is not going right, it's very tough to recover, and now you redirect all your resources towards something that may or may not work out, and that becomes one of the biggest hurdles to even consider a program sometimes.
Susheel, would you consider that as a technical hurdle as the biggest challenge?
It's a technical concern, but driven by like program timing risks that needs to be managed as well.
Gotcha. Okay. So we have two commercial, one technical. So those who are in materials technology companies, please take note. We have great scientists. We need more people who understand the commercial side.
Michael, I thought we had one of each, man.
I think
Technical,
so.
organizational, and commercial.
Yeah, exactly. Yes.
All of these are hurdles from each of our perspectives.
Sure.
It's all uphill. Barbara, I think you have a very unique perspective in this panel. We have two OEMs and one material supplier. From your seat, what is the hardest part of getting your material supply qualified by a customer?
Yeah, I think that I think there's a few things, but the first and foremost is if you don't have an exclusive agreement, and you're not doing an exclusive joint development agreement, with a customer, then you really have to first figure out market fit and whether to go all in on a design that's targeted for one specific class of customer needs, because that can be very risky. I think the second thing that comes to mind is really understanding how your material is really going to perform outside of your system and inside a customer's specific designs and conditions and with their manufacturing processes. And it can be challenging to try to separate your material's intrinsic performance from all the other variables. And then I think the last thing is, as Susheel said, timing. I think that sometimes you have to be in the right place at the right time in terms of the development cycle beginning and understanding what an OEM or a cell manufacturer's needs are very early on.
There's this risk of putting your egg into one basket, it sounds like, is one of the big ones.
Yes, definitely.
And I want to flip the conversation on its head and look at it from the other perspective. So, Susheel, like as an OEM, you're evaluating a bunch of different technologies. You're looking to where to commit to. So, when an OEM first looks at a battery material, what makes you decide that it's worth spending time and resources on?
So I think this kind of comes back to the two aspects, right? Again, first is we need to understand the benefit with absolute clarity. And for that means, does it actually have the data within the usage profiles or the testing protocols that we normally look for? And in that conditions, is the benefit actually tangible or not? And the other way of looking at benefit is also about the benefit, does it actually apply and scale at the end user level as well? Because if something is improving fast charging at the cell level, but your rest of your system is really not designed to scale any higher from current levels. And that means I really can't actually translate that benefit into an end user. Maybe in a down the road in a next product that might be true, but at this particular system level, it's not really a tangible benefit. So that evaluation itself is a big hurdle on its own, just redoing the full system level analysis to get to that answer. And second is going to be more of like a, an FMEA or a risk approach of what are all the cascading effects that will end up changing everything else in the system there. And that really becomes the biggest challenge for OEMs is like this is just one of the thousand other decisions that end up happening at the product level, and which means is that going to be now redriving a new set of safety concerns, or is that going to be requiring me to change all of the, maybe the motors or the rest of the vehicle systems or the structure around it to be able to accommodate this new change? So that evaluation is really what makes it the biggest risk. Yeah.
And from your experience, do you find yourself looking at new chemistries from a push perspective or pull perspective? What I mean is like, are you being asked from your like system level team or like your vehicle level team, like we want to enable these specs or like these features, and so we need your battery to be better? Or are you coming to your system level team saying, hey, we're evaluating this thing with this extra energy, like what can you do with it?
I think that's a very good way to think about it, and that most of the times is, where I think some materials just end up being at the right place at the right time because there is a new program direction that is being taken into, or like there's a pull from the OEM side, which of course benefits a lot for material suppliers, where we're actively seeking out and willing to make those additional trade-offs to be able to fit that in, and because that benefit is absolutely needed. And most often in those scenarios, the benefit can truly be realized because the systems are all being designed with that in mind, as opposed
Hmm.
to it being an afterthought where the benefits really start to dilute or completely even negate at a system level. So I think that depends on what's happening in the program. Is it a first generation product, or is it a product that is having a complete new user experience that requires that additional push? Or is it more of like an incremental generational update, which is most of the times at that point, it becomes a push from the battery teams into the product level teams versus other way around.
quite interesting. In terms of, and Adi, this question will go to you. I want to talk about a little of materials evaluation and especially about maturity. So when you're looking at a new technology, there's a couple of different sections that we look at. There's the material maturity, the manufacturing maturity, supply chain maturity, and the business maturity. Which one of these, from your experience, is most frequently maybe hand waved away from material suppliers and you wish that they spent more time on?
I think each of it depends on each of the projects. Like I've seen every project being structured a little bit differently, in which each of these different risks and maturities are weighed differently, and there are typically some level of disagreement around it. So I can give an example, or typically tied to supply chain. I think there is generally more confidence that supply chain, we can figure it out than has evidence has shown, especially in today's world with changing policies and a lot of different topsy-turvy. It's difficult to prepare for. So I think that's an example of a supply chain maturity, which has typically been brushed under the rug and everybody's sort of forgotten about it till it becomes a problem. I think COVID made us aware of all of that. So certainly, I think it varies for different projects. But if I were to say at a macro level from a percentage standpoint, you said let's force rank this, is which one is typically taken most lightly, I would say is technology maturity. It's what brings it's what starts the conversation is, hey, it can deliver a certain amount of watt hours, or it can deliver a certain amount of feature sets. And it's typically done on data sets that are gathered in single-layer pouch cells at a maximum, or coin cells, or sometimes it's just theoretical. So I think that's what we can put a little bit more rigor around, not just proving that it has a certain metric, but truly showing that it solves a user pain point, similar to what Susheel was just mentioning, is that how does it connect to a product and live within a system? So I think that's where I would add a lot more focus.
And typically, what level of maturity do you wish to see? Like point cell, singular pouch cell, maybe like 1 hour amp hour cell. Like what is considered something interesting enough for you to evaluate?
I think at a minimum, you want to see multi-layer pouch cells. At a minimum, you want to demonstrate that there's both scale in material and scale in when you scale it in terms of an electrode size is square centimeters, that you can replicate some of the properties, and even parasitic behaviors, mechanisms, system level impact can get proven out. So that would be where the thumbs go up or down, right? Like you can actually make a call whether this is something you can proceed with. Until then, it stays very much in this is intriguing territory.
Got it. Barbara, I want to ask you a question. I also want to recognize that Adi is a very special person in this call today because he is an OEM, but he's also very, very well versed in batteries and has been in this field and knows what he's talking about. Oftentimes, this is maybe not so much the case. And we are describing this like OEM cell maker triangle, where we have this material supplier, we have the cell OEM, and then also the cell maker. And technical qualification for new material and qualification, specifications, sometimes is lost in terms of who should own it in the specs. So from your perspective, like as a material supplier, we'd love to hear more about your experience with this dynamic and like who do you think should have the authority to say your material is ready?
The last part you said, who do you think should have the authority
Yeah.
to say it's ready? Yeah, so we have been playing in that triangle for a very long time at Gogineni, so we're well versed there. And the reality is that there is a bit of it that is a shared responsibility because as a material supplier, you're going to understand the material best. As a cell manufacturer, you're going to understand how it performs in a production environment. But ultimately, the OEM, they have the application, they know the application requirements, and they also have the customer expectation. And so at the end of the day, like my feeling generally, especially as we get into cell manufacturing at Forge Nano, is that the authority to say that a material is ready to go has to sit with the organization that's going to be assuming performance and warranty risks because ultimately I think that's what it comes down to is who has the most to lose. And so I do think that is often going to be the cell manufacturer and maybe the OEM in some cases, but I think in most cases that's gonna be really where you want that qualification decision to reside.
Absolutely. It's really about risk mitigation, it sounds like,
Mhm.
and making sure that we're able to vouch for warranties.
Yep.
I want to shift gears a little bit and also recontextualize this group that we have here today. So we have three of you joining us from your respective organizations. However, we are also connected through the Volta Foundation committee, where we're doing materials qualification and adoption. And one of the things that we've participated in recently was on the committee insights paper. And it was reframing the qualification and adoption of materials. So for those of you who don't know, Adi and Barbara are the co-chairs of this committee, and Susheel was the lead author for our committee insights paper that we wrote recently. So we have discussed this topic about how do we reduce friction in materials qualification. And Susheel, you wrote on a really interesting mindset shift. So you're proposing moving from today's material push model to more of a risk reduction parallel development model. Can you explain to the audience a little bit more what that means and what that really implies for qualification?
So I think there are a couple of things, right? Like we just talked about a lot of the friction points about why certain, materials make it, some materials don't, and why some OEMs might consider or not. And I think if you kind of take that approach and think through what do they care about and approach it from your end customers' shoes. And the first part, of course, is always going to be you have to prove that the benefit actually exists. And um, of course, given the challenges, you do have to pick a certain group of applications or maybe even a single application that you want to target. And within that application, try to go as deep as you can to prove that benefit. And because at that point, it becomes one less hurdle for the champion at the company to be able to actually convince the broader audience to be able to take a chance on that. And that on its own is not an easy one to take on. And I think there's a lot of discussion that we had and wrote about as well in terms of the infrastructure that's required to be able to enable material suppliers and not mega manufacturers to be able to kind of come to the same level playing field there. And the second part, of course, is about risk reduction. And we've seen this often where a material supplier might kind of flood you with a 40-page or report on all the testing that they have done. And you really have to dig through to find out what are the things that you care about in that. And I feel like that kind of makes the other person feel like these guys don't understand what I care about. So I think shift the mindset towards what do these people care about. And I think if you really spend some time, it's not that hard to comprehend some of the things that an OEM might worry about and structure your data in that way. And when I say structure, it's not just about reporting, it's about prioritizing what tests you're running, what data you're trying to collect first. Because if there is no data related to how much heat is generated from this cell during a fast charge, it's a complete non-starter to be able to even engage and discuss because those decisions get logged so early in the product architecture.
So really like the mindset shift is, hey, here's all the benefits that we have. Here are the testing we do for like cycle life and such, and really thinking about what does the customer care about? Like what are they trying to through the qualification process, what are they worried about in terms of the gates and how can we address those things during the development process? Um, Barbara, from your perspective, so you're a material supplier, and suppose that you're trying to do this mindset shift. So like, what does customer need? What they're looking for? Um, this can be challenging for someone in your shoes because there might be proprietary details about a customer cell design. They will explain, whatever they're using. And can you give an example of what you've experienced in the past?
Yeah, that is always a challenge to understand, especially with a technology like ours that depends heavily on all of the components in the cell and how they interact. I would say the most salient example that I have is probably on electrolytes and electrolyte additives and not understanding the systems that a customer might be using. Obviously, like a surface-based technique like ALD can do double duty with an electrolyte or an electrolyte additive, and so some of the things you're trying to solve, might have a negative impact if you are still applying, all of the additives, and we don't know about them a priori. And then, I mentioned some of this prior that just different manufacturing conditions. You can be starting with the same active materials and all the same components, but if you're don't get transparency around formation schedule even, or stack pressures for pouch cells or the loadings of the electrodes and all of these things, they can have an impact on whether or not you're actually comparing apples to apples results.
Absolutely. And especially in silicon, the question is always how much FEC do you have in your electrolyte? No one willing to answer that question.
Absolutely.
Um,
Yeah.
as a follow-up, so you have typically two options. Either you ask your customer to disclose what their electrolyte formula is, or you try to develop representative reference systems. From your experience, what has gotten you further?
Yeah, so I think that having a process where we start the process very open and we're given reference systems, that is always super helpful. At the end of the day, that takes us much further, much faster. But we also understand that that can't always be the case, that there's going to be proprietary IP that has to be protected. And so what really works is a combo approach. We have to understand the critical items that might affect interactions and materials performance. But ultimately, the more that we can know about how the material is going to be tested and what specific test protocols as well as components are going into the cell, that moves a process along much, much faster.
Totally agree. We're at a quick time check. We're about 3 minutes out from having questions. So I want to close our panel with a round robin question to ask everyone. We've discussed many different things about maturity of material suppliers from all different aspects. We discussed the risk reduction model versus the material push model. And really, like, OEMs and cell makers have to be able to vouch for whatever technology and risk that they put into their designs. And to do so, this is why a lot of this friction exists. But if we're able to think of this perspective a little more saliently, instead of this material works, this material is going to get benefits, maybe this will reduce the friction there. My closing question to all of our panelists: if you could change one behavior by one party in the material supplier, cell maker, and OEM dynamic tomorrow, what change do you think would most accelerate responsible materials adoption? Start with Susheel, and then we'll go to Aditya, and we'll close out with Barbara.
So I think it's the most tricky one to solve this, right? And I think there's two aspects to this. One is it would be great to have a shared vocabulary and a common nomenclature that we are using across. Uh, and I think it's not most of the times it's not really about confidentiality, because some of the fundamentals that drive a vehicle design or a consumer electronics design don't really change that much. And I think OEMs need to be, more clear about this is the items we care about, this is the data that we want, and have that be in a standardized structure. That way, everybody upstream of your product are able to plan these out, because these things take like 5-7 years to start development all the way making it into a consumer's hand. So I think that clarity from an OEM is going to be so important for them to be able to reap the benefits down the road.
Absolutely. And I think that's saying a lot coming from someone who's seen both ends of the spectrum of qualification timelines, either like 12 to 18 months to 3 to 5 years. Like, yeah.
Yeah.
Adi?
I believe I'll start by saying the one behavior by one party is probably, I'm going to dismiss that portion of the question and just rephrase it a little bit as what one behavior can we change? And I think as we discuss a lot of this around the risk reduction model, my one behavior that I would change is acceptance of different risks at different stage gates of the process. So I will illustrate this with an example. So let's take an example that's common for hopefully many people on this call. Talking about the moisture sensitivity risk of a high nickel cathode material at the early stage coin cell level is a risk that will easily get resolved as the project progresses. So that risk can be named, it can be written down, and we can move on to the next risk that we need to solve. I think what happens in this entire multi-stage gate product introduction from material to OEM to product is risks get misplaced on that spectrum of the process. And we spend too much time in de-risking in one area when we can easily let it pass through. So the one behavior I would change is understanding which risk and where can it be placed so that you can move quickly through this process to solving some user pain points, which is what the goal is.
That's also a very good one. Thank you. And Barbara, please close us out.
Yeah, I mean, I'm obviously going to say that the OEMs and the cell manufacturers need to change their ways. But I'm honestly going to say that I think that one thing, we obviously have to stop operating as three separate siloed activities, and I think that the cell manufacturer has an opportunity to be that bridge. I've always thought that it would be amazing if cell manufacturers could do calls for materials, kind of like grant solicitations, where they clearly define qualification criteria as well as like barrier to entry tests so that we could reduce that noise and it would kind of level the playing field so that smaller materials manufacturers could compete against, in that playing field with larger manufacturers, and there'd be some self-selection with these barriers to entry. And so I don't think it's a behavior that that self manufacturers need to change. I think it's one that it would be lovely if they adopted.
Perfect. Thank you so much. All right, we're going to move to our questions Q&A section of this call. So if you have a question, if you feel comfortable, please raise your hand and we'll call on you to ask the question live. Or if you don't feel comfortable, please put them in the chat and we'll try to answer them one by one. We have one question that came in during the call. Is there a basic product requirement document, a PRD, that is shared with material suppliers? Without that, there can be no conversation that can move forward meaningfully between supplier and OEM. I'm sure you'll have a lot to talk about PRDs, but I'm curious your perspectives.
Could you repeat that? The voice did cut in and out for me.
Is there a basic product requirement document here or PRD that is shared with material suppliers during this MQA process?
For sure. I mean, we are able to share what the product requirements are. So like any product that comes from what the user requirements are, and then it gets distilled into each system and subsystem level requirements. We are able to share that with partners we believe have promise and can get us there. So certainly it's something that we spend a lot of time and effort on in understanding user requirements and translating that to some silicon expansion test that you can validate whether this will work in that system. So very much part of the process.
Yeah. Susheel, do you have anything to say?
So I think, I think the PRD is a good way to kind of structure some of the discussion that we just had, right? Because, and it's to Adi's point earlier, it's not just about also showing the requirement. If the PRD can clearly lay out what are the data sets that are needed at what phase gates, I think that becomes a very strong signal to the material suppliers on what data they need to prioritize. And I think just increases awareness across the supply chain.
We have time for maybe one more question if someone is interested in asking a question. All right, so Motion has asked one. So does the communication stop when a material passes qualification? Or is there a feedback loop continuing beyond qualification? So after cell materials has been integrated and released into the end application?
I'll start by saying for new materials, passing qualification is you reach base camp of Mount Everest. You need to still climb the mountain, which is pretty much the rest of it, sustaining production over the course of the lifetime of the product. That's where a lot of the stress happens and where the unsexy work happens, where you have to drive continuous yield improvements, quality improvements, drive down cost, and so on. So I think that's just the beginning of the work and the relationship. There's a lot more afterwards.
Just want to comment, Mohsen, if your cell supplier is contacting you after mass production, that's probably a bad sign. So typically, if they don't contact you, that's usually means that nothing's going wrong.
They'll definitely
Right, perfect.
for pricing, that's for sure.
Yes, absolutely. Just want to give a quick round of applause to our panelists, Aditya, Barbara, Susheel. Thank you so much for this conversation. It was quite interesting to engage with all of y'all.
No, likewise. Thank you, Michael.
It was a
Thank you.
pleasure.